Okay, so we have insulin breakdown. Breaks your sugars down, right? 5% per minute. So ate a whole bunch of sugar. Need to take my insulin shot so I can bring down that the extra sugar count, because for whatever reason my pancreas is not working, it's not cutting down my sugar. So I have to have injected insulins to help my body break down the sugar, right? So I'm going to do 10 units because that's what my body count asks for, okay? My body weight, okay? So I'm going to take 10 units. What's my function? So is this decreasing or is this increasing? Decreasing, right? We're breaking down the sugar content, right? So that means, is it decay or growth? It must be decay. So in other words, it starts here, but it's going to break down. That's what the graph's going to look like, right? The function, well, what is the basic function? Remember, the function with respect to time is equal to A, right? The amount you start with, times 1 minus, because this is decay, it's going to be minus R to the T. Oops, sorry. R to the T. Now we know it does 5%. So now the A we started with was 10 units times 1 minus 0.5 to the T. So now we're talking about 10 times 0.95 to the T is f of t. That's your function, right? And so now we just have to plug that into your calculator and graph it. It should look like this, right? Because it's decay. But let's find out what it does look like. Come on, open up. All right, so we're going to change this from 1.03 to 0.95. And we're going to change the 580 to 10, right? Woo! All right, look at that. That looks different. Okay? So, we can see, oops, whoa, hey, come on. All right, we can see that it's crossing at 10 and it's going down, right? Can we see that on there? Okay? And it's going down. And so we have our graph. All right. We wanted the graph. We go, okay, this is our graph. And at 20, at 10, we're coming through here. And then at 10 and 20, by 20 we're going to come down a little less than a quarter. So right about here. So whoop. Okay, so that's our graph. Okay? All right. What we want to know is after 10 minutes, how do I know exactly what it is after 10 minutes? Well, I take my calculator and I go 10 times 0.95 to the 10, right? Per minute. Remember, this was per minute. So after 10 minutes, so I just raise that to the 10. So I go 10 times 0.95 raised to the 10 equals. And that's 5.987. That's how much is left. But we didn't want to know how much. Well, we do want to know that much. But hey, what we really want to know is when will we be at a half dose? When will we be at 5? And that's pretty hard, isn't it? You have to keep plugging in numbers until you can figure it out. Or, because we have this trusty-dusty calculator, we can look at the calculator and we can look and go, hey, where is it at 5 when I have 5 left? So is that 510, right? Okay. Wait a minute. Is that 10? So wouldn't that be 5? You got me confused. Here. Let me just do this. Boop, 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 boop. Come on, man. You were working so good earlier. boom, boom, boom. Okay, just boom. There you go. Alright, when will I have 5? I will have 5 at, looks like, at 13.5. Something like that. So it looks like around 13. 13 minutes. Okay? And again, we need an easier way than just looking at the graph and kind of trying to figure it out. And that's what logarithms are going to do for us. Logarithms are going to let us figure out this function, right? Exactly. Okay? That's tomorrow. That's not today. All right.